So we just finished our discussion on lever systems, lever arms, and torque. Now we're going to look at an example in which we're going to want to calculate the net torque on our lever system, knowing the various forces that are acting on that system. So let's suppose we have the following system. So this system is composed of two wheels. Wheel A that has a radius of 30 centimeters and wheel B which has a radius of 50 centimeters. Now wheel A is placed on top of wheel B and an axle is placed in the middle, and this axle is the point about which the two wheels rotate. So these two wheels are connected to one another via this axle. So we want to calculate what the net torque is on our system knowing these two forces. So force number one is acting on wheel A, and it's acting at a 90-degree angle to the lever arm of wheel A. And the magnitude of this force is 50 newtons. Now, this force has a magnitude of 50 newtons as well, but this force is acting at a 120-degree angle to our lever arm. So lever arm RB, which is 50 centimeters. So that's why when we calculate the force of this guy, we actually have to calculate the X component force and not this force. This force corresponds to the net force, but we want to actually calculate the X component. Why? Well, because we want to find the force that acts at a 90-degree angle to our lever arm, which goes directly this way. So we want to find what this component force is. So let's begin by first figuring out which direction this force pulls our wheel and which direction this force pulls our wheel. So if we pull on this force, we see our wheel rotates in this direction counterclockwise. Likewise, if we pull on this wheel, we see that this force corresponds to a clockwise rotation. So once again, force 1 acts to rotate counterclockwise, while force 2 acts to rotate clockwise. Now let's choose one direction to be positive and one direction to be negative. So let's choose the clockwise direction to be positive. So clockwise meaning in this direction. So this force is positive while this force is negative. So now we want to calculate the individual torques, and then we want to sum them up to find our net torque. So let's begin with force number 1. So force 1 acts at a 90-degree angle to our lever arm, and that means to find the force, we simply take the force, the magnitude of the force, and multiply it by the lever arm. So force 1 multiplied by lever arm equals 50 newtons multiplied by, so it's 30 centimeters, but we want meters. So we simply divide by 100 and we get 0.3. So 50 times 0.3 is 15. So this is my torque that's acting in this direction, in the counterclockwise direction. Now let's find the torque in a clockwise direction. So once again, we want to find the X component force. So we have to multiply our magnitude of force by cosine of this angle, because cosine is adjacent of the angle multiplied by our magnitude. So the torque counterclockwise equals the force or the magnitude multiplied by cosine 30 multiplied by the lever arm, so this distance, the radius. So the radius is 50 centimeters, divided by 100 gives us 0.5 meters. So 0.5 multiplied by 50 newtons, our magnitude of force, and multiplied by cosine of the angle 30. And that gives us 21.7. So 21.7 newtons per meter is our torque that's acting in the clockwise direction. So that means now we have to add the two guys up. And since this is the clockwise direction, this comes first. So 21.7 minus this guy, because this is the counterclockwise and we chose this to be negative. So 21.7 minus 15, and that gives us approximately 6.7 newtons per meter. So this is our torque, our net torque, that's acting to accelerate our system, so our system will rotate in the clockwise direction going this way.